Okay, this is our last example for section 7.3, applications with quadratic equations. In this example, a rock climbing club planned a climbing expedition. This actually happened when I was in college. We planned a rock climbing expedition. The total cost was $900, which was to be divided evenly amongst the members going. Okay, so the cost is $900. There's probably somebody taking them, and that's what they charge for a group. Okay, while practicing, 3 members fell and were injured, so they couldn't go. So my response would be to immediately resign from this club and find someone that's a little bit safer. Now, this actually happened when I was in college. I actually planned this rock climbing expedition, and then I got sick, so I couldn't go. But they had to pay the same amount, so they just had to pay a little bit more. So this is actually just like something that happened with me. But here, it's 3 members that fell and are injured and can't go. Okay? If this resulted in a price increase per person of $15, how many people went on the expedition? Okay? So the cost is $900 regardless. It's split evenly amongst the people who actually go. Right? You don't know how many people were in the club, but you do know that 3 of them couldn't go. And the price per person then went up by $15 per person. So how many people actually went on the expedition? Now, your first instinct is probably just to try to figure this out in your head. But we're not going to do that. We're going to use algebra. Okay, so the first thing we do is figure out a variable. And for this one, you might as well make it the number of people who went on the expedition, since that's what they're asking for. Then at the end, you'll have x equals, and you'll have your answer, right? How many people went on the expedition? So write that out. It's called declaring your variable. So you can refer back to it so you don't get confused and lost. Okay? That's why people get lost with word problems, is because they absolutely refuse to write down stuff that's like signposts along the way, breadcrumbs you can follow, you know? And that's what declaring your variable is all about. The previous problem, I did that by drawing a picture and labeling the sides. Here, I don't have a picture, so I'm just writing out x equals number of people who went. Because there's other people. There's the number of people who fell. There's the number of people who originally were going to go. So be specific. Don't just say number of people. You know, be specific. Number of people who went. Okay, x plus 3. What is x plus 3? Well, the number of people who went, you know, there's 3 people who couldn't go, right? Because they were injured. So x plus 3 is the original number of people who were going to go on the trip. Why do I want that? Because I want to know the price, the original price per person, and the new price per person, right? So I need to know how many people planned to go originally, and that's x plus 3. I don't need to know the number, I just need to know the expression for it, x plus 3. Okay? So now the cost per person originally, and notice I actually wrote all that out. I'm not just writing some fraction out and trying to keep in my head that it's the cost per person originally. Why? Because the more complicated problems get, the more ridiculous that becomes as a strategy. So might as well start now doing things well. Okay, so I just wrote out cost of person originally was, and then I can think about it. What am I thinking about? Oh, I forgot. Oh, it's the cost of person originally, per person originally. Well, it was $900 total. And how many people went? Well, I wrote that down. See how I wrote that down? Number of people who went originally planned to go. is x plus 3. So I'm going to divide by x plus 3. Okay, that's the cost per person originally. Now, after the 3 people injured themselves and couldn't go, the cost now, the actual cost of the trip is 900 divided by x. It's 900 divided by the actual number of people who went. And I look up here and I see x equals number of people who went written right on my piece of paper. Okay? That makes it easy. Now, you have to put these two expressions together into an equation. And the only piece of information we haven't used is this right here. This resulted in a price increase. It should be, right? 3 fewer people going should cost more. Of $15 per person. This is the cost per person originally. This is the new cost per person, which should be more, right? It's more because with 3 fewer people, each person has to pay more. So there's a difference of 15 between them. Now you could take the bigger one minus the smaller one equals 15. Or you can do what I did, which is just the smaller one, the one where everyone was going to go, plus 15 equals the cost of the people that actually went per person. Okay? So that's kind of, there's different ways of setting that up. Like I said, you could take the difference of these two expressions and equal 15. I just did it that way. I figure out which one's the smaller number. The smaller price is the one with more people going. So that's 9 over x plus 3. And the larger one is the 900. The larger one's the 900 over x. So I have to add 15 to the smaller one. That was my reasoning. Okay. Now what do? You have an equation. This is a rational equation. You have to multiply both sides of the equation by the common denominator. Least common denominator is x times x plus 3, the quantity x plus 3. And you have to multiply both sides of the equation, which means all 3 terms. 900 over x, 900 over x plus 3, and the 15 all get multiplied by x times x plus 3. So just write that. I wrote it out for you just so you get that, right? And you might even write down the GCD equals and write what it is if it helps you, because then you're just moving that in front of the numerators of each of the fractions and multiplying the 15 by it. See? And I kept them the same color so you could see. All right? Now, all the denominators will cancel, otherwise you did this wrong. This is why you're multiplying by the LCD of the least common denominator. So on the first fraction, the x's will cancel. The second fraction, the x plus 3's cancel. And then I just rewrote this without the x, the ones that canceled, without the ones that canceled. Okay? Distribute the 900 through right here, right? To get these two. I just copied that down. That's nice because it's going to cancel with that. They're on opposite sides of the equation, notice. And then distribute the 15x. So I should get 15x squared and 45x. And then I'm going to, right, the 900x's cancel off because that's one on each side of the equation, right? So subtract 900x from both sides. And then what did I do? Well, on the right side of the above equation, you see that there's a 15x squared plus 45x. I like the positive exponent, so I just leave that, and I'm going to take this 27, move it to the right, it becomes minus 27. And then instead of writing 0 equals this 15x squared plus 45x minus 2,700, I just wrote the equals 0 on the right instead of on the left. Okay? Now, don't put that in the quadratic formula. That's insane. Notice that there's a common factor of 15. 15. That one's obvious enough. 3 times 15. And I know that's something times 15. Why? Because it's 10 times something, which means it's 5 times something. And 27 is divisible by 3. Right? So 15 divides this. So I got out my handy dandy calculator and divided 2,700 by 15. And I got 180, right? With the minus sign, of course. That's much easier. Now I need two factors of 180 that differ because of the minus sign here. The two factors, one's plus and one's minus, right? Because that's minus, and whenever that's minus, you have a plus and a minus factor. And they have to differ by 3. So it's kind of too bad it's not 18 and 10, but it's not too much harder than that. It's 15 and 12. It's kind of fun. You divide 2,700 by 15, you get 180. Then divide it by 15 again, and you get 12. Anyway, that equals 0. So one of these is minus 15 and one is 12, right? But the minus 15 you cross off, not because numbers can never be negative, but because what these numbers represent. X is the number of people who went on the expedition. It's not -5 people. That would be 15 people appear from an expedition. Okay, so 12 people went on the expedition. Now you can check this real easily because you know the numbers. This is just arithmetic. Right? So if the total cost was $900, 12 people went, you just divide 900 by 12, it cost them $75 each. Now, if the 3 people that hurt themselves went, there would have been 15 people who went. So that would be $900 divided by 15, which is $60 each. Notice they differ by $15, which is exactly what we were told at the beginning here. Right? So that's correct, and I know it's correct. This is the thing about math. You want to know you're correct. You don't want to be guessing about anything. Okay? So that's my answer. X is 12. They only asked for the number of people who actually went. And that's it.